Subtraction is the root of so many problems for our students. Have you ever noticed how much easier it is for students to add than subtract? That's because students are usually taught to add before they subtract. Even though we call it counting, we're actually teaching how to add by one. When it is time to subtract, they only subtract from positive values. Ultimately, subtraction becomes a function of adding. Or in other words, you have to have positive numbers in order to subtract from. This is an oversimplification that causes problems down the line because students are not taught about negative values. Students are kept in the dark about the other side of zero. Limiting concepts like these might be making math more difficult for our students later in their academic progression. If you start with an unstable foundation, everything built upon it is shaky as well. All additive or cumulative operations start from working with positive values. Counting is your first introduction to adding. Once you begin to master addition, you are then ready for repetitive adding, which is multiplication. Once you understand this, you can move on to exponents and distributive properties, resulting in polynomial expressions. If you struggle with adding at the beginning, that would make every new additive concept more difficult. If we look at subtraction, the first introduction we have is usually counting backwards. Once you can subtract by various values, you can then progress to repeated subtraction, which is division. Division is tough. In my experience, even simple division by 2 is a struggle for students without a paper or visual aid. This immediately sends a red flag up that the subtraction is not fluid. If students are already struggling with division, you can see why they all hate fractions, because fractions are basically unsolved division expressions. Students are usually lost by this point, and the expectation is for them to move on to factoring and roots. They end up having to rely on rules, shortcuts, tricks, and calculators. I believe it goes back to that world we never talked about, the one we left out, the other side of zero. We set this struggle up. Look at the operations learned in each level of grade school math. Students add and subtract starting in the first and second grades, but are not really taught the concept of negative numbers until middle school in some cases. So we are taught only half the numbers in existence, and then we completely crush their world at 11 years old by introducing a completely equal and opposite world of negative numbers. You might as well tell them they have an identical twin and they were separated at birth. Now go catch up for lost time. It's not a coincidence that the difficult areas that students struggle with are all connected. All of the topics that students struggle with the most are all related to deconstruction or subtraction and dealing with negative values. If we can get them to understand early on that negative numbers are equal and opposite to positive numbers, we may be able to strengthen their understanding of concepts that are connected. We actually have a lot of common examples of the world of negative numbers. Every winter, we hear about below zero temperatures or the wind chill factor. This model alone should pique their curiosity, as they should wonder, if zero is the lowest, how could we go below that? We have all been in buildings with lower levels or multiple lower levels. Why are the numbers increasing as we get lower? Kids love dinosaurs. These amazing and powerful creatures exist in opposite time. Working with the prehistoric time or timelines would be great as a way to engage children on the primary school level especially. Everyone has had the unfortunate event of going to the bank and seeing that their balance is negative. How can you have a negative balance? How is it possible to have less than $0? Students can begin to learn early on how to consider or count personal debts. This may also be an opportunity to ingrain some financial literacy concepts. Children definitely understand the concept of owing something. Concepts like these are tougher when you spend most of your math education working with numbers on the positive side of zero or dealing with zero as if it were the lowest possible number. This is one of the major misconceptions that students have. Zero is technically the middle. It is in the middle of infinity and negative infinity. One way I like to demonstrate this is to have people stand between two facing mirrors, as if they were in a dressing room. What do they see when they look left? Repeated images of themselves going further and further away. Then they look right. The equal and opposite situation. In between these two worlds is the viewer, who represents 0. What if we have students get familiar with using negative values earlier on? People are taught to use their fingers to help them count from 1 to 10. The visualization helps for accuracy and memory. In their hands, they literally hold the numbers. The concept of negative values could be reinforced using a similar model. If they place their hands in front of them with their palms up, they technically have a number line. The right hand would hold the positive numbers and the left hand would hold the negative numbers. 0 would be in the middle where they have no fingers. The thumbs would point in opposite directions, which would reinforce the concept of equal and opposite values. It's up to you how you teach negative values in your classroom. But they have to be introduced as early as academically possible and reinforced consistently. Whether you want to do backwards day or opposite day, reverse day, it's really up to your own creativity. Anytime I wanted to do drills with negative values, I would have the class skip count by different values going up and down. Find some of the everyday ways that negative values are used and drive home this concept, because in doing so, you strengthen all the other concepts that they will build on the foundation of negative values and subtraction.